Kazakhstan, long known for hosting the legendary Baikonur, is now pushing to become a space power in its own right. It's manufacturing satellites, exporting technology, and training a new generation of engineers. But the real question is, can this ambition actually lift off? Or it's another project that looks great on paper, but struggles in orbit. Hi, I'm Aida Haidar. Let's find out what's really happening behind the walls of Kazakhstan aerospace industry. Kazakhstan is not a space superpower, and the story starts exactly there. Right now, I'm standing in one of the most advanced manufacturing facilities in Central Asia. Here, engineers assemble optical systems and satellite payloads, the brain and eyes of spacecraft. In the past 2 years, Kazakhstan has gone from buying foreign satellites to building and exporting them. There are already contracts with Mongolia and Republic of Congo. That's a big leap. And what's driving it? And what still holds it back? That question is answered first, not by engineers, but by strategy.
I think the answer is really simple, because most of the huge countries, I think, they got an interest in these countries, on these republics as minimum. For example, if we took for Nigeria, there is a lot of mining companies who is working from China, from Russia, from United States, from Europe. To get this data from satellites, they want to be more independent, because if you company who developing source of data, you can somehow, it's not official way, but it's not legal way, but you can somehow fix them. They want to get like independent access, because Kazakhstan not involved in these regions. We are not have interest in Mongolia, in Nigeria, in the Republic of Congo, so we are open to transfer knowledge, whatever they want. And our main goal to give them independent satellites. They can get full access, not dependent at us at the end of the project. So I think this is a key.
This is not power politics. It's contractual trust.
We are on the development stage, so we will, as I mentioned, we will develop together. I hope that we will learn from them as well. We teach them for some stuff like developing satellites, integration, other stuff, how to operate satellites. But on other case, for example, in Mongolia, they have really good IT guys who doing coding very well. I know that in Republic of Congo, they have guys who are working for a long time with ground stations, for example. I think it will be win-win cooperation in that case, because we still have something to learn from them, and we can teach them, they can teach us. I think it's a win-win approach.
Contracts don't work without people who stay.
I think in Kazakhstan you can be more fast promoted and get more access to new technology. For example, I got a lot of peers who studied with me, who still working maybe in the United States or in Europe. As a foreigner, usually you have limited access, and your promotion should be somehow limited as well. So in Kazakhstan, for example, when I started here, it's I've been an engineer. Now I became CEO. I've been CEO of 2 companies. I've been system engineer. I've participated in creation of this center. I've been part of satellites program. So for you can grab more knowledge, more experience, more faster, because we are limited by engineers. For us, it's critical. You can be part of few different programs at once. So in short time, you can be higher expert than working abroad.
How long it took you to become CEO?
I think 15 years. Everybody from Europe think it's a really short trip.
It's very, very fast.
Yep.
Fast because the system is still being built. Building a satellite is one thing, using it effectively is another. This is where the data comes down: images of forest, rivers, farmland, and even border zones. Kazakhstan's Earth observation satellites like KazSeoSat-2 feed into everything from agriculture to environmental protection. But the big question is, can Kazakhstan turn this data into real economic value, or just science for the show? Someone has to carry that responsibility every day.
The main thing that what we do here is we are operating 2 Kazakhstan Earth observation satellites that were launched in 2014, and we are operating them nominally. Everything is functional. And right now we are at the spacecraft control center. And what we do here is we are controlling our satellites. So they are KazioSat-1 and KazioSat-2. They are made by two different companies. The first one is produced by Airbus Defence and Space, and the second one is the English company called SSTL. So they are operating at different altitudes, and they have two different missions, let's say. What I said, we are controlling, we are operating them here using our two ground stations here at our location. And well, basically we are controlling everything about satellites, how they feel themselves, so their health. We check everything, all parameters, and we are receiving what we call telemetry. This is our main tool for analysis. And if we see something that goes wrong on board, we first of all we are analyzing, we are identifying the problem, and then we fix it. And then what we need to do is, what we must do is, we need to put our satellites in operational condition every time, because we need to make some images every day, because we have some, let's say, orders from our government and from some commercial customers. So we need to provide the data to them.
At some point, space stops being abstract.
The most memorable thing was the first picture that we took in 2014, since we launched our KazioSat-1 satellite. And this first picture was the center of our country, Astana, and especially Akorda, where our president is. These satellites can take pictures of some, let's say, some emergency situations. For example, this year we took some pictures for Philippines, because we are a member of different global
Multilateral institutions.
Yes, so we provide the data that we are collecting from our satellites for them, to help them to analyze, to see the amount of damages and everything.
Before satellites are controlled, they are tested brutally. I was told that this year is the last moments when a person from public can actually access this place, because it's going to be closed for a major project. Maybe you can tell us what the project is going to be about.
Yeah, sure. So starting from next year, we will be closing this facility completely, because it's going to be clean room environment. And in order to enter this facility, we need to have a special closing, because it's going to be a clean room environment with ISO 8 grades. And it's very important for us to keep our satellites, our subsystems very clean. Over here we've got a compact antenna test range. It's an asset contribution of Airbus Defence and Space to Galam. It's a one-of-a-kind facility that has only a couple of countries. And the main purpose of this facility is to test communication satellites. And as you might know, communication satellites are located 36 to 40,000 kilometers above the Earth. And in order to simulate that distance, we need to make sure that our satellite is being tested in this chamber. So what we do is we mount our satellite over there, and over there we've got a signal generator that generates signals that would keep hitting those two reflectors until it reaches 40,000 kilometers and it reaches back to our satellite. That way we simulate the distance of geostationary orbit to Earth. And those are the values that give us basically what are the attenuation gains, what are the things that we need to configure on our satellite, so that we know exactly once our satellite is on geostationary orbit, we know exactly what are the values and what we need to do.
What is this big black hole?
It's a thermal vacuum chamber. The main purpose of this chamber is to simulate space. As you might know, in space there is no air. So what we do is we put our satellite inside, close this door, and suck all the air. That way we create a vacuum, and also we play around with the temperatures. So there is an environmental chamber, so we can heat up our satellite all the way up to plus 170 degrees Celsius and freeze it all the way negative 120 degrees Celsius.
120.
Yeah, so it's considered to be the most expensive test in our facility. It can take all the way up to 6 months because we burn a lot of nitrogen, we also burn a lot of electricity.
For decades, Kazakhstan's space story has been synonymous with Baikonur, the legendary launchpad of the Soviet space program. But the country's space ambitions go far beyond that. Today, Kazakhstan not only designs and operates its own satellites, it also develops technology, manufactures components, and runs missions under its national flag. The real question now is how far to go. Should Kazakhstan invest in building full launch capacity at home or concentrate on strengthening satellite production and data-driven services that are already taking off? So you see, Kazakhstan is truly a space nation. There's progress, there's manufacturing, engineers are gaining in experience, export contracts. So whether Kazakhstan can sustain this momentum will define not only its place on aerospace map, but how it's going to see itself in the decades ahead.